Today we have an incredible opportunity to have Cynthia Bell with us. She is going to share an instructional routine for building number sense and using structure. And go ahead and to the next slide. Okay. During her session, we'd like you to use the chat to introduce yourself or share links or resources with the group, and also to ask questions to the group. We will use the chat to share links and so on. Use the Q&A though for asking content questions, and we'll ask them to the presenter. We will make sure to answer as many questions as we can by the end of the session. Next slide. As you know, you'll get a follow-up email with a ton of resources from this session, including the recording, the slideshow, a summary sheet, the chat transcript, the Q&A. You'll receive your certificate, information for our scholarships, individual membership, and then you'll get a separate email with registration links to the coaching sessions. These coaching sessions are an opportunity for you to meet with Cynthia and talk about the instructional routines that she presents today, talk about any questions you might have about bringing instructional routines to your classroom. It's a great opportunity to get some small group interaction. Please register for one of those. And what are they? So 1 to 3 weeks after the webinar is usually when we schedule the coaching sessions. Each session will have up to 12 participants, so please sign up soon. And then it's an opportunity to expand on those topics that I talked about previously, the instructional routines in this case, and opportunities to talk to the presenter and others in this group to talk about how to implement this. Go ahead. Additional resources include our scholarship for everyone that applies for the scholarship. We invite, excuse me, for everyone, we want to invite you to apply for the material scholarship, which is about $1,000 for New Readers Press materials. You'll get a classroom set, student books and teacher guides. Danielle's going to put that in the chat box for you, so you have the link to apply for that scholarship. It is limited, so please don't delay. Make sure you click that link. Some additional information: free 1-year individual membership to ProLiteracy is available to participants in these webinars. We have an additional link that we'll put in the chat box. And the deadline to apply for the membership, the free 1-year membership, is May 10th. So please make sure you go ahead and apply for that one free year. Next slide. A new interactive voting guide is now available. It is free, and the interactive voting guide comes to you from ProLiteracy and the easy-to-read weekly newspaper that we have, and the website for new news for you. The guide explains who can vote, why every vote counts. It describes how people in the U.S. choose their leaders, and it tells your students how to register to vote and cast their ballot. It's a really awesome opportunity for your students to learn more about the election process. Next. And I will hand it over to our wonderful presenter, Cynthia Bell. Thank you for participating and enjoy the presentation. Cynthia, you're on mute.
One more time. Hi, good afternoon,
Thank
everyone.
you.
As Maribel said, my name is Cynthia Bell. Welcome and thank you for coming. And we're going to just go ahead and dive right into the session that we have. So I have some objectives for us today, so we're all clear on what our expectations are and what we're supposed to get out of our time together. Articulate. For you to be able to articulate your understanding of instructional routines. So I always start with what instructional routines are, just to make sure we're all on the same page, especially if you haven't attended any of the previous sessions. to understand the value of facilitating effective number talk. So we're going to talk about number talks today, since this one is instructional routines that promote number sense and structure. And our third objective is that we're going to take some time to reflect on implementation of the two routines. So we're going to actually engage in the routines, but I also want to give you a chance to kind of spend a little bit of time thinking about what it would look like if you use that in your practice, whether it's in your classroom or tutoring one-on-one. And then, as Maribel said, we have follow-up coaching sessions. So I wanted to give you an idea of what would happen if you attended one of those. And that's really where we get into what it would look like if I actually did this specifically in my class of what about this? What about that? And that you would have some like specific concrete ideas of how you could implement the routines specifically into your classroom or into your practice. So that's what I hope for us to get out of our time together. If this is your first, second, or third, well, first, second, if you've attended all three, go ahead and give me a thumbs up in the chat box. I kind of want to give you a shout out if this is your third and you attended all three. If you were only able to make it to two of them, you can give me a thumbs up too, just so we can all see where we are collectively in our understanding. But how this works is we're going to start off with a warm up because I think it's important to prime your brain for learning. So we're going to do a little bit of warm up. Oh, look at all those thumbs ups. I love it. Look at all those thumbs up. Okay, so we're going to do a warm up. And this is called this or that. This is actually a instructional routine, but it's not even the ones that I'm going to introduce, but I always try to sneak another freebie in there for you guys. And this is our warm up. So this is a this or that. And the instructional routine is pretty simple where you choose this or that. Danielle is going to drop a poll for us. And so the question that's going to be on the poll that you'll get a chance to respond to is if you had to answer one of these using only mental math, which one would you prefer? So Danielle, if you could release the poll for us, please. Oh, look how fast everybody's responding. You were quick to the draw. You knew what you wanted to say. I'm actually anxious to see what the results are. A lot of times I do this question, the results tend to be the same. But I'm curious where you all are landing. Another 10 seconds to see if any of the other participants here would like to respond. Okay, we're at 80% response rate. So Danielle, can you tell us? Oh, I get to hit end poll. Let's see, can I share the result? Oh, it's exactly what I thought it would be. Most of the time, I get around 80% of the people that say 32 times 5. So if you can, I try to make our webinars as interactive as possible. Can you type in your chat box why you chose the answer that you chose? Whether you chose the 97 plus 48, or the 32 times 5. Take a moment and type your response in the chat box. Why did you choose the one that you chose? Let's see what we all think here. I can add faster because of the 5. Addition is easier for me personally, fewer numbers. I really wanted there to be a neither. That's actually funny. Easier for me to break it into 2 chunks. Addition. Oh, it's going fast now. I can't read as fast. I can add faster, fewer numbers, easier to route. Okay. I like doing this or that as kind of a warm up sometimes just to get our brain percolating, primed and ready to learn. And they work really well with number sense. So just to break down some of the math concepts here, as I said, about 80%, and we were at 76%, about 80% of the people, when I do this, pick the 32 times 5. And a lot of the answers are kind of what I'm seeing here because I know my 5 times tables because multiplying by 5 is easier. But I actually always pick the 97 plus 48 personally because I feel more comfortable decomposing and recomposing. And 97 plus 48 is not air math for me. And those of you who might be like, what's air math? You know what I'm talking about, where you actually write the 9, 7 in the air and you write the 4, 8 underneath it. You'll draw the line and everything. I don't do all of that. I decompose and recompose. I see 48 and I see 97. I take 3 away from the 48 to make 97 100. And then I clearly just see the answer is 145. But likewise, I could also decompose and recompose 32 times 5. So if I feel like being cheeky that day, I'll pick 32 times 5 and I'll decompose and recompose that such by using the strategy of halving and doubling, where if I take half of 32 and make that 16 and I double the 5, then I just got 10 times 16. And that's really easy for me to see as well. So that answer for me is 160. So those are different strategies that I use, but our topic today is about number sense and structure. Both decompositions and recompositions that I gave the strategies, I used structure. I use what I understand about patterns and structures and number sense, and I use that structure to help me to be able to figure out the answer. So I thank you all for participating in that, for giving me your responses why you chose that. I did this in the practice session yesterday, and that got some really good, interesting responses as well. I don't know if anybody wants to share anything about that, but if not, we'll move on. Okay, so I feel so old school. I do it regular way. See, I want to ask questions. I hope you come to a coaching session. I want to know what regular way is, right? Like that's why I said the air math thing. And the air math was kind of like that algorithm of I've got to write the 97 and the 48 underneath it, and then carry the one and all that other stuff. Number sense and structure are really good tools. So let's talk about instructional routines here to make sure we all understand what they are and why you should use them. They are specific and repeatable designs for learning that support both you and the students in the classroom. And one of the things that I really like about it are these keywords here: building crucial math thinking habits. Think about the warm up that we just did and the thinking habits that I expressed that came from me trying to solve this problem. Those thinking habits for me were decomposition and recomposing, decomposing and recomposing. Also a little bit of commutative property, right? Like they start to build those thinking habit muscles the more you do them. And what are some reasons why you should use them? Here are 5 of them, but I'm highlighting the 3 that are really going to come out the most in today's session. They make the math visible, build mathematical habits of mind. I kind of just talked about that, right? There are a lot of habits of mind. Most of them are really connected to those standards for mathematical practices, like specifically number 7, look for and make use of structure, right? Or number 1, make sense of problems and persevere in solving them, right? That's a mathematical habit of mind. They're also really good for developing mathematical and academic vocabulary. So that's a good way to get like language learners or even native English speakers to start using like the vocabulary, right? Like listen to how I express my strategy. I said decomposing and recomposing. And it's okay when you first start doing it, students aren't saying those words, but these are the opportunities for you to start to build those words in actual context rather than just like a glossary of terms that's on chart paper in your classroom. Generalizing and making use of structure, and for formative and summative assessment. I talked about that one a lot in our second webinar on how I use these things to assess, especially formative assessment. It tells me what my student knows instead of me giving them a worksheet saying, fill this out, let me know what you know about fractions. If I did a this or that with fractions, it's going to tell me a lot about what they know. In fact, I just did a this or that when I was tutoring a student the other day, and one picture was of a proportion and the other one was of multiplying fractions. And I did that because I wanted to know if they had like that procedure of cross multiply and divide stuck in their head, and if they would misapply it when multiplying fractions. So I just did a this or that, and I did it as a formative assessment. I wanted to know what they knew. And by listening to their responses, I learned a lot about their understandings and any misconceptions they might have. So those are reasons why you would do an instructional routine. One more thought on instructional routines. A well-designed instructional routine opens up conversations. And that's what we're going to talk about today. We're going to talk about number talks or just talks in general. And this is what a good instructional routine will do. It gives students a chance to think and talk about math in ways that they might not have already done for themselves. So maybe you haven't heard of this concept of the number talk or a math talk before. So I want to just stop there to make sure that we all kind of know about a number talk or math talks in general. And there's this really great resource out there. Maybe you've heard of it. If you have, or if you've even read it, let us know in the chat box that, yeah, maybe I've heard about it or I've read it before. You think it's a good book. You've tried it before. But there are like 5 steps or practices for if you want to run an effective math talk discussion productively in your classroom, in your instructional practice. And I just want to highlight for you a couple of points here that for me stand out. Anticipation is key. You kind of always got to anticipate ahead of time, like what are the responses you're going to get? Like, for example, with the this or that. I said going in, I'm like, I anticipate that about 80% of the people are going to say 32 times 5, right? And not just that, but I also anticipate like the responses that I would get as to why they're choosing 32 times 5, as well as the answers that I'm going to get as to why they're not choosing the addition. So anticipation is important. And thinking about that ahead of time, monitor student work and specifically solution pathways. And then these two kind of go together, select and sequence. So if you're going to try to run a productive math talk, you want to start to like select student responses. And it's not always this is the right response, right? You want to try and select student responses, and then you want to sequence them in a way that makes sense to like move through the discussion. And then the last step is connect. You always want to go back and make sure that like you're connecting to the main idea, to the concept, to other representations, to other math ideas. And these are like the 5 practices for running that talk. So I have 3 key points of an effective number talk. And if you're taking notes, I really hope that you like write this down or make this mental note in your head. And the first one is like the most important one to me as a math instructor, as a math practitioner, as a math educator. Honor all student thinking. That is the first key point to an effective number talk. Honor all student thinking. And what do you mean by that, Cynthia? I mean, if I'm running a number talk and I'm asking for strategies and I'm looking for strategies and I'm selecting responses and I'm going to write the answers down on the board. That's one of the things that you do. You write the answers down, you write the strategies down. But what sometimes happens is if we don't hear a response that we think is right, then a student shares it. And if we don't write that down or we don't bring it as a point of discussion or an idea, sometimes that shuts that student down, right? Like they're like, I shared my thought and you didn't write it down, but then the next student shared their thought and you wrote it down. Think about what that does to that learner. They probably put themselves out there in the first place to share their thinking, and then you basically didn't honor their thinking by writing it down. So that's the first thing, honor all student thinking. I'm glad that you shared your thought. Let's dive into that more. I'm going to park that here, right? Like I'm going to write all of the different strategies that I'm calling on. That's what selection is about, right? Like I selected the strategies and I'm going to make sure that I honor it. I'm going to write it down, even if I know that strategy didn't get them to the right answer. Or promote, our second effective key point is promote different solution pathways and strategies, which again is connected with our selective sequence. Different solution pathways and strategies, because that is what's the richness of a number talk. All the different strategies that come out, even if they're not your strategy, even if they're not the strategy you had in mind as to how you add those two numbers together. But when you promote the different solution pathways, you never know if the pathway that is shared is the one thing that a certain student in your room needed to hear, that one thing they needed to hear that made something click in their mind. So for example, the 32 times 5 one that we did in the this or that, the strategy that I shared was halving and doubling. That's not my own strategy. I was in my early 30s before I even heard that strategy. And do you know where was the first time I ever had that strategy? It was in a number talk. I was in a room full of math teachers and we were doing a number talk, and that strategy came out. And I was like, wait, what? Like I had never even heard this strategy before. I'm like, what's this halving and doubling thing that you're talking about? Then my brain started like thinking about this mathematically. Does it make sense? Is it reasoning? Of course. Oh yeah, it makes sense. Decomposing and recomposing. And then I tested it with other numbers. Like I didn't even have that strategy, but I heard it because someone shared it in a number talk. So promote different solution pathways. And then our third one is make the math visible, which is connect the practice. Help the learners to see the relationships, to see the patterns, and to see the structures, to connect again, like that last practice there. Connect, help them to see it. It's not just this abstract thing. And so those are 3 key points. If you're going to try to run an effective number talk, you have your 5 practices there. But while you're engaging those 5 practices, consider and remember these 3 things. Honor all student thinking, promote different solution pathways and strategies, and make the math visible. And then you're good to go. I'm going to pause there to let you all really reflect on that for a second, because that was a lot of information. And I want to give you a chance. As I said, our objective is to reflect on your practice. So if anybody has any questions about how to run a math talk or any of the key points, or if anybody wants to share any of the thoughts that they're currently having, I'm going to pause here to give you a chance to do that in the chat box. I agree with you, Danielle. It's fun to see how students from different countries solve math. And I've been in a number of conversations with math teachers where this comes up. And some people feel very strongly about how you should not let those students share those pathways because it confuses the other people in the room. And I'm sure you all can guess which side I fall on. Because again, that one strategy might be the one thing that that person who is a native English learner, native USA math learner needed to hear, because the algorithm that they've learned in class all their lives is not working for them. And then someone from a different country goes, oh, this is how we do this in my country. That might be that one thing that that student needed to hear to unlock long division for them, because it's always been so complicated. Divide, multiply, subtract, bring down. What do I bring down? When do I bring it down? Where do I put the number? And then someone else goes, oh, but this is how I solve it. Anybody else? Students sharing different strategies, way to connect with more students in the class. I agree. I agree. Maribel, did we get any questions?
Nope, no questions in the Q&A.
Okay. Everybody is good at something, so find what they are good at. I like that. I like that. Okay, so all right, Cynthia, I think we got it. We got the reasons why and all those other things. Like, what about the routines? But someone just dropped something in the chat box and it made me think of a quote that I heard. I was at COABE last month and I went to this really great session, and the presenter gave this quote. And now I want to say it out loud because of the comment that Kate just dropped. The more we understand as teachers, the more that we can say yes to students' good ideas. Like, that really resonated with me. And that's kind of like what you said. Everybody's good at something, so find what they're good at. And that's your statement, Kate, made me think about this quote. And that really has to do with like the anticipation and all the other things that we're talking about and looking for student strategies. We have to be open ourselves to not just our way of thinking about something. And we also have to be open ourselves to have deep understanding of the math. Because if we have deep understanding of the math, then we can say yes to students' good ideas more. Right? That's why I really like this statement. The more we understand, it's like the more math we understand, and the more our way of thinking is challenged, the more that we can say yes to students' good ideas. There you go, Monica. I said it over time. The more we understand, the more that we can say yes to students' good ideas. And I don't know about you, but I kind of really want to do that. I don't want to just be like, no, that's not how I solve it. Or no, let's not talk about that right now because it's going to confuse other people in this room. I want to think about a strategy a student gives and why they're giving it. And let's see if I can connect it and help them to understand the connection and the way they're thinking about it. Hence, make the math visible. All right, so let's do some instructional routines. Here's technically the first of the 2, but if you're really paying attention, we kind of already did one, and that was this or that. But I said I was going to do 2 instructional routines in this webinar, so this is the first of the full-on 2 routines, okay? So the first routine is called Same But Different. And here's how you do the same but different. And I'm actually going to drop these notes in the chat box for you all after I tell you what they are. So here's how you facilitate a same but different. You're going to see 2 images on the screen, and you ask your students to look carefully at the images for how they are the same but different. And the second step, which we're going to actually do this, think silently by yourself first. You really want to promote giving students and learners time to think by themselves first. Even the ones who immediately want to turn over their shoulder and talk to a partner, you want to encourage them. No, everybody takes some time to think for yourself first. Then step 3, share with a partner or a small group your ideas. And then step 4, record learner responses. That's what I'm talking about in the number talk, right? You want to honor those student things. You're like writing down the responses on your whiteboard, on your chart paper, and maybe even like putting their name on it, right? Like, oh, this is what Maribel said. Oh, this was Bridget's strategy. Oh, this was Monica's strategy, right? So share, record learner responses, ideas on a board or a T-chart of how the two images are same but different. And then number 5, summarize learners' ideas and call attention to connections. Hence our 5th step, right? Connect, make the math visible. So I'm actually going to just give you those 5 steps right now in the chat box in case you are a visual person and you want to see them. There you go. So we're going to actually do it. We're going to do a same but different. In fact, we're going to do 3 of them. So I hope you're ready. Everybody take a deep breath. Okay. So I'm going to give you the 2 images. You're going to think silently about your first self first. And then since we're in a webinar, you're going to have to type your responses in the chat box, right? This is the part where we can't necessarily share with a partner, but you can share with the group, okay? So please do not type your responses in the chat box just yet. I want to make sure we all get time to think silently by ourselves first. Then when I tell you can put your responses in the chat box, then you can do that, okay? So here's the first 2 images. How are these 2 things the same but different? And this is a low floor, high ceiling task, right? So you have a chance to literally say things like, oh, they both have a 0 in it. You can do that, right? There is a low floor accessibility. You can get as high in mathematical philosophy as you want to, okay? Think first. All right. Now, can you share with the class, can you share with the group your responses? How are they the same and how are they different? Both pink. I like it. And I like that because, as I said, there's no wrong answer here, right? Low floor, because maybe that's what your students can tell you. Some same numbers, same answer, opposite tens, both have the same product. Oh, look at all that math vocabulary is coming out. Opposite tens, both have 2, 3, and 0. How are they different? Different grouping. Interesting. See, if we were in class, I'd be like, what do you mean by that? Same numbers, same action, same product. How are they different? Both multiplication and the same combination of numbers 2 and 3 and 0. I don't think I saw how many have their ways how they're different. I'm seeing a lot of how they're same. Okay, different order where 0 is placed. Ooh, that's interesting. Like when I just read your answer, Julia, of where the 0 is placed, my brain started buzzing. I'm like, ooh, right? Like a whole bunch of math stuff started happening in my head. Different order, different set of tens. What else do we have? Different grouping. I got that one. Okay. All right. So now we're going to make the math visible, summarize learner ideas, and call attention to connections, right? So some of the connections I'm seeing that they're the same as far as like, yes, they're both using multiplication. Yes, they're going to both have the same answer, AKA the product. And then how are they different? Oh, I didn't hear it, and here's a chance where I would pull out some vocabulary, right? I heard someone saying something about grouping. And so I'm wondering, right? This is what I would do in the class. I'm wondering if that grouping has to do with the commutative property or if it has to do with the associative property. Right? Like I would throw that out there. I have what I call like push and support questions. That one would be like a push question. I want to push some people who are giving me those answers about grouping and tens. I want to push them to think a little bit more deeply about that. Some other summarizations I might want to pull out are what we're talking about the tens and how that does or does not change your answer and why doesn't it change your answer and what's being grouped here. So there's a lot of like rich math number sense conversation that can be sparked from doing a same but different activity just like this, right? Like you as the teacher, you have in mind the specific number sense concept that you kind of want to poke at, that you kind of want to pull at, and then you design your same but different accordingly. And then you kind of sequence and connect your answers and strategies around that. Okay, we're going to do another one because I want you to see like different ways that it could be, because it doesn't have to always have actual digits in it. Here's the next one. Take your time, think first by yourself. Don't write your answer in the chat box. How are these two things same but different? All right. You can go ahead and give me your thoughts, and your ideas, and your strategies in the chat box, please. They're both blue. Yep. Ooh, both can be translated to one another. Percents are easier to work with. I think that's subjective, but I love that I want to know like why. I love that. That's same but different, both part of a whole. Ooh, that's interesting. Ooh, I'm seeing math, academic vocabulary come out. Express a ratio in different forms. What do you mean by that? Is that a same or is that a different? Both can represent the same product. I would say the same thing. What do you mean by that? Right? Like, I'm always going to try and push. Like, what do you mean by that? How are they the same or the different? Both have 7 letters. Oh, is that true? Two, three, five, five, four. Wow, I never noticed that. One has a dot. Okay. One will be a number you can use in an operation, and the other you need to, oh, it's going too fast, manipulate before you can use it in an operation. Again, I would ask, what do you mean by that? Right? Sometimes like the push and support questions can literally be that, right? Like expound on your thinking. And I would like for the students to say those things, not for me, right? Because the student who gets a chance to articulate their thinking, one, they're deepening their learning, but also it promotes student to student conversation instead of student to teacher, teacher to student, student to teacher, right? Like I would ask those questions to say, what do you mean by that? And let that student explain that math idea or concept. All right. Thank you all for sharing. Both are ratios expressed in different form. One is easier to visualize. What do you mean by that, right? Like, could you show us what you mean by visualize and how it is easier? Um, Next one. Thank you all for sharing. This is our last one on this one. Decimals has 7 different letters. Percent has 6 letters with one that repeats. Oh, okay. I love that. Like you're like now looking at it even more, right? Like I did not notice that thing about the 7 letters. Okay. All right. Here's our last one. Take a second, think. This one is geometry because I really wanted you to see that you can do same but different with so many different things, so many different images. You can have numbers, you can have words, you can have pictures of shapes of things. Here's our last one. Okay, go. Both involve lines. Both have 2 lines. Don't forget the difference. Don't forget the difference. One intersects, one never will. Ooh, you know what I'm about to say, Jennifer? What do you mean by that? Right? Same use 2 straight lines, arrows on both lines. Both have 2 lines, but one creates parallels, one is perpendicular. Different. See, there it is. I was looking for me to sequence. I was looking to see if anybody was going to say anything about the angles. And I saw one answer that came out about the angles. Where to go? Someone said it and then it went away. One has a 90-degree angle. One has a little square. Oh, I like that. And Kate, I would say, what do you think that means and why? Why do you think one has a little square and the other one doesn't? Both are infinite. Ooh, Tammy, what do you mean by that? Both contain lines that are infinite. You too, Jennifer, right? Like, I want you to think now, excuse me, as a teacher, think about the richness of a conversation, of the math learning that could start to happen in your class if you use this instructional routine, especially if your goal and your objectives is to help build number sense or to help students start to build and look for structure. And then also, I want you to think about the concept of an instructional routine in general. because I noticed this. The first one that we did with the pink numbers, the number of responses that I got was not as high. But then when we did the second one, I got more responses and deeper thoughts about things, and people were noticing letters and things like that. And then the third one, you guys were like ready to go. And that is the beautiful of an instructional routine, right? They're repeatable designs. The more you do them, the more the students understand what you're looking for, and they're going to go deeper. And that's what instructional routines do. It sets an expectation, a level of expectation. So that way, when I say same but different, everyone in the class knows exactly what's about to happen. Or if I say notice and wonder, everyone knows what's about to happen. We're going to look at something, we're going to notice, and then we're going to wonder. Same but different. I know she's about to give me two images, and I'm going to have to think deeply about these things and try and find connections to how they're the same and how they're the different. I agree with you with teaching ESOL and GED. And that was the last point I had about this. This instruction routine works really well across all contents areas. At COABE, I actually presented on in the science strand on instructional routines for science. And I did same but different. I did it with math, and then I did it with science. And the two images that we looked at was an image of a lunar eclipse, like the what's happening in space. So it was like a picture of a sun, and then there was like a shadow, and then there was like the moon and the earth. And then right below that, the second picture was what happens on a solar eclipse. And it had like the sun, the shadow, the earth, and the moon, right? And we did same but different, right? And so like think about you could understand what students already know about solar and lunar eclipse by doing that, hence formative assessment. But also now think about all like the science, ideas, concepts, connections that come out of that. And I did that at COABE in a room full of like instructors. And the conversation got really, really rich. It started out kind of like low level as far as people only seeing like, oh, they named like four things. And they're like, well, that's everything. And then it started opening up more where people started noticing things like someone was like, oh, I noticed the color of the moon is different on a lunar eclipse compared to on a solar eclipse. Oh, that's interesting. Why do you think that is? Right now we get to talk about, oh, the shadow. And actually, the shadow is what's coloring the moon. And that's why it's a different color, right? So, same but different works great with all content areas. I agree. ESOL, ELL. I do this with paragraph photographs and ELL. Tell me what you see. And now you get to go a little bit more, right? Like what's different? And I just want to be clear that this is not the same as compare and contrast, especially if you start really going after math concepts and ideas, which is what you will have to do as a teacher, right? I'm going deeper than just like compare and contrast. Tell me how these two things are alike or not alike. But mathematically, conceptually, let's now really talk about like what parallel lines are. Where do you see them? How do you see them? What kind of angles do they produce? You guys started coming out with those things in our chat box already, okay? All right, so here's our second instructional routine. This one's called Would You Rather. I've been loving this one lately too. It's called Would You Rather, and it's really that simple. I would give you a question, and I try to find images too, so I can have multi-sensory there. You know, you hear it, you see it. Um, and you just select Would You Rather. So again, there's no wrong answer. You'll see two option choices. And you ask the students, which one would you rather choose? But when they choose it, you have to justify why you've chosen what you've chosen. So I'll give you all an example. Sometimes when I'm not, like when I'm first introducing the instructional routine, I don't do anything like math related. I just want to get them familiar with the routine. So the first one that I'll do is like, would you rather say every word that comes to your mind? Well, sorry, is would you rather have to say every word and thought that comes to your mind forever, or never ever speak again? Oh, I didn't change it yet, Natalie, right? Like, so I'm just giving you like that's the I do that. I introduced that one as a means of like getting the students to understand how the would you rather would be, and everybody would pick one and they'd have to say why I chose this, well, because, and it turns into this great conversation. Okay. So I'm going to show you all the slide for the would you rather. And first, take a moment, think to yourself, choose your answer, and then I'm going to say you can write your answer in the chat box. I'm going to give you two more caveats right now. I promise you that when I put the slide there, you may find yourself going, but wait, I need more information. Or you may find yourself saying, well, I have questions before I can decide. And that's okay. I want that to happen to you. But I'm still going to say you have to choose one first. Okay. All right. Everybody ready? Here we go. Would you rather have pennies to match your weight or quarters to match your height? Wait, this is our thinking time. It's okay. I really want you to think about it because remember, you can't just pick one. Your answer has to be that you picked one and you tell me why. All right, there we go. You can pick one, but you cannot just pick one. You have to pick it and then say, here's why. Quarters equals more money because I don't want that many pennies. Quarters, I am tall and thin. Height in inches or feet. See, there's that question, Bridget, right? I was like, somebody's gonna ask it. Somebody's gonna be like, I need more information. Quarters because it might be more money. Again, right? Like these are the first kind of like first layer answers that I get. And then here comes that push in support, right? And then you're sequencing. I'm getting those answers, and now I'm going to sequence the answers that I have, and I'm going to push each one. Tell me more. What would you need to know? Why? What's your reasoning there, right? This is how I would facilitate that conversation if we were actually being able to interact with each other more than just like me here and you all in the chat box. Quarters because 6 feet of quarters result in more money than $2.50 a penny. Okay, here's a couple of push and support questions that I would have for you. Are you creating the limits in your thinking for yourself? Meaning, what I mean by limits, meaning like, did you set for yourself what the units would be? Right? Like, or did you set for yourself what the relationship would be? Like, did you say it was 1 penny for every pound or 1/4 for every inch? And if so, does it have to be that? If so, do you have to use the imperial system? I did this with a student one time, one-on-one tutoring, and the first thing she said was, I want to use the metric system and I'm going straight to milligrams because I can get more that way. And I was like, ooh, that's interesting. And the first time I saw this, the first thing I wanted to know was how many grams does a penny weigh? And how tall is a quarter? Right? Like I wanted to know all this information so I could make an informed decision. Let's see, Marcy said quarters because even 0.25 times my height in feet is great. Oh, it would wait, is greater than 0.01 times my weight in pounds. Okay. But again, in pounds, who says you have to use pounds? Maybe you could use ounces. If you used ounces instead of pounds, would you have more money then? Are they still made of copper? These are all really good questions. I did a lot of research when I found this out. I was like, it depends on what the quarter is made. I mean, the penny is made out of, and that determines how heavy it actually is. Okay. So, like, think about all the math and inquiry that is happening to you right now as a learner. I don't know about you, but I want that same thinking and mathematical habits of mind to start to happen for my learners. I want them to start to question and to think and look for strategies and look for connections in math and not just mimic and memorize. That's been like my model this year. I don't want my learners to just mimic and memorize my way of thinking. I want them to understand their way of thinking and test for reasonableness. And if it's mathematically sound, and if it is, then keep going. Find your solution strategy as long as it's mathematically sound and does it make sense. And you know, the best way for them to build those muscles is for them to engage in these kind of routines in your classroom. Julie said, will the numbers of penny match the number on weight? Or will it be the weight of the pennies to match the weight? These are all really good questions, Julie, and I believe that you have the right to decide that. Because if you all notice, this is a very open question. I didn't give you barriers, and I didn't give you barriers for a reason. Another would you rather that I like to do when I'm working on ratios and proportional relationships. In fact, I was tutoring last night and I did this exact would you rather. And the question was, would you rather make $50,000 a year and everyone around you only makes 25,000, or would you rather make $100,000 a year and everyone around you makes 200,000? I'll say that one more time in case you're like, wait, hold on, what? Would you rather make $25,000? Sorry, $50,000 and everyone around you makes 25,000? Or would you rather make $100,000 and everyone around you makes 200,000? Every time I've asked that to students, I get different answers every time and different reasons why. I had one student go deep into inflation, and she was like, well, if everybody's making 200,000, then inflation will go up really high and everything will be really expensive, and I'm making 50% less than everybody, and so everything is still really expensive and I'm making less than everybody, so no, that would be the worst thing ever. And I was like, wow, you just said so much math in the last 10 seconds from this one question, right? Is there a pool and a tennis court available? It's inflation economics, right? So point being, I'm just giving you examples like would you rather is a really good instructional routine that can work for whatever content that you're thinking about. So maybe I've got you percolating and your brain is buzzing and you're like, well, where would I get these things? How would I come up with those? These are all really good questions. I'm glad you asked them. So here's some resources for the talk. And when I say the talk, I'm meaning like all of these are considered math talks. And there are different kind of math talks. Like there are number talks. We've kind of been engaging in number talks, but there are also these lovely things called dot talks. I really like dot talks. And then there's fraction talks. So here are a couple of resources. First of all of these resources are going to be on the follow-up sheet that you're going to be getting in your email from Danielle, but I kind of just wanted to let you know what you're looking at. So Math Strat Chat is from Pam Harris. She's one of my favorite math educators that's out there. And she's the creator of the Math is Figure Outable books and website. And I just love that title. I don't know about you, but I just love that title. Math is Figure Outable. And I'm like, of course, right? It's figure outable because you can reason and make sense of things. And those are habits of mind. And those habits are not formed in one go, hence routines. And this Math Strat Chat is like, it's like basically a chat on Twitter where she does these kind of things. Like she'll post some weird math question like this or that, or would you rather? And math educators from all over the world respond, and we all have like this chat online. So you can go there and get some ideas. Maybe you're like, well, I want to try this, but I don't know where to start. You can go there and get some ideas as well as see different reasonings. And that will help you with your anticipation part. Then this one here, Math for Love, is from a website that talks about fraction talks with blocks. And fraction talks are really good, especially if you're dealing with fraction and helping students deepen their understanding and math number sense around fractions. Fraction talks, they have those using blocks with pattern blocks. And then the dot and number talk, as I just said, dot and number talks are really good ways to build number sense. And dot talks basically help students to subsitize and groupotize, right? Like it's a thing our brain actually does where we can look like at a group of items, but apparently only look up to five. Some people train their brains to see seven, where like you can see five things and not actually have to physically count them. Like your brain can look at that and go, that's five beans, that's four chairs. But anything greater than that, your brain doesn't physically count them, but your brain starts to subitize. It starts to put those things in groups of five or less. And then you figure out how many there are. And that's how they do different dot talks to help train your brain around that, looking for patterns and structure kind of thing. Dr. Jo Bowler runs this website here, UCubeEd. She's my favorite math educator. She's out of Stanford. And she's got a lot of really great resources there. I already gave you like specifically this link here to an actual lesson plan. Like you could take this and teach it tomorrow. So it's one of her lesson plans on how to run a dot card number talk. And then the last thing here is if you want to know more about instructional routines, because we've only done 3 webinars, and in the course of those 3 webinars, I've introduced 6, possibly 7 instructional routines. but maybe you want to know more about them, you can always visit the Adult Numeracy Network. Several of you probably are already members. If you are, shout out to all the ANN members out there. And you don't actually even have to be a member to access this page. This page is on the front end where you don't have to be a member, you don't have to sign in, and you can access our instructional routine page. And there are about 34 instructional routines there with resources on how you can get there and how you can use those instructional routines. So with that, I'm going to pause to see if anybody has any questions. I'm seeing some questions, but I think they're more of conversational here. Is that like the math is not mathing? Except I would be like, I think that's the opposite of math is not mathing. I think when a student is in their math is figure outable mode, that's when their math is mathing. And I actually like to say that to them. I'm like, ooh, that math is mathing. Like, look at all that reasoning and sense making you're doing. Look at that mathing. Would you rather buy a liter of gas in Canada with US money or a gallon of gas in the US with Canadian money? Oh, that's a good question, Danielle. But as soon as I read it, my brain goes, wait, I need more information. How much does a gallon of gas cost in Canada? Right? Like, which is what you would want your students to do. Any other questions? Maribel, do we have any in the Q&A? She said a lot.
No, there are no questions in the Q&A.
I don't know if that's a good thing because I explained everything really well or a bad thing because
I
I
would say
didn't.
it's a good thing. I think you've done a great job explaining all of these instructional routine activities.
Okay. Well, I will pause here to hand things back over to everyone. But before I do that, I mean, to the pro literacy people, but before I do that, I would like to say thank you all for coming, and especially those of you who thumbs up that you've attended all three. I sincerely and truly hope that these were effective and that I might see you in some of the follow-up coaching sessions so we can really dive into what this would look like if you were going to try it in your classroom or anything like that. So I'm going to move through the next set of slides for you all and let Maribel take it from here. Um, here's the information again about the registration links for the coaching sessions. I believe Danielle's going to drop them in the chat box too.
And thank you, Cynthia. That was a great session. We'd like you to take a moment to fill out our survey. Put your camera to the QR code and scan that so that we can use your feedback for to improve our sessions. There is a question. Is there any way we can get the recordings from the previous two sessions? Yes, the recordings are available, and I believe Danielle will include them in the email if you have any questions about that. Any other questions? Do you want to go ahead to the last slide? All right. Danielle put all of the links for the upcoming coaching sessions and the link to the previous webinars in the chat box. If you have any additional questions, you can reach out to Cynthia through math@proliteracy.org. Thank you so much for attending today, and we look forward to seeing you at the coaching sessions.